So you should have last few days talked about how to find the least squares regression line via the calculator, or just be given to you. So we're just going to talk about one more way you can find it. So one important property that you should have learned is that the least squares regression line always contains the point of the x bar and the y bar, which are the mean of the x variable and the y variable. So there's a formula, and it's on the formula sheet. So we're going to do b sub 1, that's slope, can be found by taking the correlation r, which we're going to talk about today, times the standard deviation of the y values divided by the standard deviation of the x values. So this is on your formula sheet. So once you find the slope, and these three things would be given to you somehow, either in the problem or in a printout. So once you're given that, you have the slope, and so to find the y-intercept, you know that it always goes through x bar, y bar, so you have the slope, you have the y average, you have the x average, and you're going to find b sub 0, or the y-intercept, by just solving for the variable. So let's do the example here. So you're given these pieces of information, so you should have enough. So we're going to find the slope first. So we're going to do r times the standard deviation of the y's divided by the standard deviation of the x's. That gives you 4.65. So we know the slope, and we also know that the y bar is one of the points on the regression line, so that's the y. And then you take the slope and times the x bar, since we know that the x bar is the point that goes with the y bar. And you're going to find the y-intercept. So solving for the y-intercept, negative 152.25. So your y-hat equation, so remember, always put the hat on there. If you have the variable names, we need to write that in there. Hopefully that's been emphasized to you over the last couple days, so we need variable names. So there is our equation for the least squares regression line. So just point out here, make sure when you're calculating the y-hat equation, you cannot interchange the x and the y. It will be a different equation, so be careful of that. If your correlation is 0, then you have a slope of 0 and you have a horizontal line. So y-hat is just y bar going straight across like that. There is no linear association, so x has no relationship to y. It's not helping us predict it at all. So correlation, so that's the r value. It's called the correlation coefficient. So just looking at graphs, it's really not a good indicator because it can depend on how they scale it and exactly how the graph is made to see how close the points are into a line. So this is a numerical way to quantify how good the relationship is. So we're going to calculate the correlation coefficient. So that's telling you the strength and the direction of the association, the linear association. So what does the scatter plot not tell you? So hopefully that again has been emphasized. It does not tell you causation. So just because you have a relationship between two variables does not mean that one was causing the other. Okay, so things about the correlation coefficient. So that's the r value that you've maybe have seen before. It's always between negative 1 and 1. So here's some examples. So this is a pretty high r value. You can see that the dots are pretty close to a line, all close together in a pattern. That's a really strong correlation. This is a 0.51, kind of a linear-ish pattern. It is going up, but they're not very close together in a line. This one really has no association at all, so you get your 0.01. And then you can also go in the negative direction with that negative slope, still pretty close to a line, pretty strong relationship. So there's not really any way for you to calculate r other than using it on your calculator to be given to you. This just goes through how it's calculated. It has to do with the standardized scores. So your z-scores for the two, and then they graph it and things like that. So you don't really have to understand that at all, but that information's there if you want it. So you can kind of just ignore that. Make sure if you are using the word correlation, let's talk about it as the correlation coefficient. So say association if you're talking about anything else other than the correlation coefficient. And just in case it comes up, it's also called Pearson's correlation coefficient. So some things we need to know about the r value. The r value has absolutely no units. So if you notice, I said before, it standardizes it into the z-score, so there's no units involved in the R value. So height and weight, it doesn't matter if you'd measure it height in centimeters, inches, whatever, or kilograms or pounds for the weight, you still have that same association, so it doesn't matter what units are in, so the R value has no impact, there's no relationship to what the units are. The R value does not depend on which variable is x and which is y. That relationship still stays the same. You might get a little bit different graph if you do switch x and y, but the R value will remain exactly the same because you are standardizing everything and you're multiplying, so the order will not matter. So what's negative, what's positive? So if you have a positive association where your dots are generally going up like that, when R is greater than 0, when R is less than 0, you have that negative association where they're generally going down. As R approaches either your positive or negative 1, you have a stronger relationship. It's positive 1 if you have a positive association, negative 1 if you have that negative association. And the closer you are to 0 on either side of 0, you have a weaker relationship and more scatter. So the only time that you have exactly positive or negative 1 as your R value is a perfect linear relationship. So if your data are in a perfect line, so x exactly determines what y is. So that doesn't happen very often. Things to remember. R value is a measure of the strength of a linear association. It measures how close the data fall to a straight line. So an R value near 0 does not mean there isn't a relationship. It's just not linear. So you can have quadratic, exponential, you can have all sorts of other strong relationships, but that's not talking about the R value. Just like we've hopefully been doing for the scatter plots, both variables must be quantitative in order to have an R value, so numerical. You can't do it with categorical data. So hopefully earlier on you talked about resistant and non-resistant data. So is that R resistant or non-resistant to outliers? So think about if you had all these and then you kind of put a dot down there. That's weakening the relationship. So that would be non-resistant to outliers because you are going to go ahead and change how strong the association is with one dot not in the pattern. So if you are doing correlation, you should be looking at standard deviations of x and y. That was talked about earlier. Even though R measures the strength of a linear relationship, it does not absolutely tell you if the linear model is appropriate. Okay, so when I come back on Monday, you should be looking at residual plots. And those are what are going to tell us my pen stopped working, so I'm going to type. So residual plots. And we will talk about that on Monday. So residual plots are going to tell you if you have a actual linear relationship. Because if we're going to look here, you can have a pretty strong R value even when a line is not the best fit. So if you look at this first graph here, if you did your linear regression line, you kind of get it going here. This is clearly not linear, but the points are still going to be really close to that regression line, so I get a pretty strong R value. In here, it's not super strong, but it is more linear. So here, you get a strong R value where a linear relationship's not the best option, but here, it's not super strong, but a linear relationship is your best bet on this one. So just be aware, R by itself without looking at the graph or the residual plot, it does not really actually guarantee that you have that linear association, so be careful with that. So I hopefully earlier in one of the days you talked about what happens when you have the outliers. So kind of just think about what happens when you stick points in different spots. So if you have, so let's say this graph here, and you stick a point further out here in the pattern, even though it's further away from the other data, you get a pretty strong association, so your R value is going to go up. If you do a point like up here that's not really close to any other data, it's going to weaken your association, so your R value will go down. So you want to talk about either closer to 0, or closer to 1, or negative 1. If you do it kind of here, it doesn't strengthen it as much. So we want to talk about also, remember that it's anchored at the point x bar, y bar. So if you think about x bar, y bar kind of being in here somewhere, it's like a teeter-totter. And your line will go closer, get pulled up towards this. So if I get pulled up here, my line gets kind of pulled up this way on the end. We'll talk more about that when I'm back as well. Last thing we want to talk about, don't confuse correlation with cause and effect. Just because you have a strong correlation doesn't mean that the X is the cause of the Y. So for example, you can see that Baskin-Robbins sales in ice cream is strongly associated with drowning deaths. I don't think it's the ice cream sales that is causing it. It's summer, people are swimming, that's the cause. So there's going to be an association, so there's probably something else going on. There can be other things going on impacting both of them that sees that association. Here's another example. Fresh lemons imported, total U.S. highway fatalities. There looks like there's an association, but I don't think it's exactly the lemons that are causing the highway fatalities. So just make sure you're never proving cause and effect just looking at a scatter plot or using an R value. We'll talk about how to do that in Chapter 4. So in case you need to find your R, and it's not showing up when you run your linear regression, you're basically going to go to the catalog. So you hit second, and then the number 0, and then you'll get the catalog to show up. And then you want to find diagnostic on, and then enter twice, and it should now show up whenever you run linear regression. And if you need help with that, I can help you when I get back, or your sub probably can help you with that one as well.